Okay, concept of rigid and non-rigid rotors. It is assumed that the bone length remains fixed during rotation of the molecule, which is rigid rotor. It is assumed that the bone length remains fixed during the rotation of the molecule, which is rigid rotor model. However, the molecules rotate, the atoms are subject to centrifugal force, which stretch the bone is the non-rigid rotor model. In short, rigid rotor bone length fixed, non-rigid rotor bone length flexible. In molecular spectroscopy, especially in the microwave region, molecules are often modeled as rotors to study their rotational motion. The two main models are rigid rotors and non-rigid rotors. A rigid rotor is an idealized model of a rotating molecules where the bone length between the atoms is assumed to remain constant during rotation. Molecule is perfectly rigid, no stretching or bending of bones. For example, a diatic molecule like hydrochloric acid, if the bone length is considered fixed, it behaves as a rigid rotor. Rotational energy levels are given by E j equal to s square at pi square I, j plus 1, I moment of inertia, j rotational quantum number. Non-rigid rotor. A non-rigid rotor is a more realistic model where the bone length is allowed to change slightly due to centrifugal stretching. When the molecules rotate faster, molecules' bones are not perfectly rigid and they stretch at high rotational speeds. For example, oxygen or nitrogen molecules at high rotational energy levels, the bone length increases slightly due to centrifugal force, making them behave like non-rigid rotors. And the corrected energy levels are Ej h square at pi square I, jj plus 1 minus dj square jj plus 1 whole square d centrifugal rotation constant.